Hi, how's everyone doing? I hope good, yeah, a lot of energy. I hope you guys are enjoying Ignite. I know I am. This is actually a great conference. And I'm actually speaking for the, let's see if it works. There we go. I'm speaking with the session Microsoft Azure DocumentDB and Azure HDInsight Better Together. This talk will cover this talk will talk about some of the basics behind Azure DocumentDB, HDInsight, how they play together. A short intro about myself. My name is Andrew Ho. I'm a PM on the product team for Azure DocumentDB. A quick raise of hands. How many people are familiar with Azure DocumentDB? Oh, that's pretty good. Yeah, good number. Nice. How many people are familiar with Azure HDInsight? Okay, slightly less. Okay, cool. How many people are familiar with Hadoop and Storm? Okay, nice. Very nice. So these are some of the things we'll be talking about within this talk. So to get started, I want to ask a quick question. Who went to yesterday's talk for John had a talk about select latest from DocumentDB? Anybody attend that? Okay, awesome. Awesome. Yeah, that's weird. So he mentioned in the talk that the Azure ecosystem is kind of like a toolbox. SQLDB is like the hammer. DocumentDB is like a drill. And I really want to emphasize this point to everyone because this is really true. The modern application is not built on one service alone. How often have you seen anyone build a house with a hammer alone? Not many, right? I can't imagine that's a good house either. And Azure provides all of these different tools. Let's say Azure Search, Azure DocumentDB, HDInsight. It's auto going. I'll just keep up with it and I'll keep moving it back. You guys get a preview now of what I'll talk about next. Okay, yeah, so it's kind of like a toolbox where there's different tools. And you get to use all of these tools together in order to build a great application. Especially with the modern application, the needs are great, and using the Azure ecosystem, you can build something truly magnificent. And in this talk, I want you to understand what kind of tools Azure DocumentDB and Azure HDInsight are, so that you can better. Let me see if I could quickly fix that. Technical issues. Cannot find any type of auto. Does anybody know why this might be auto going by itself? Raise your hands. Nobody? Okay. Huh?
Check the presentation mode.
Presentation mode. Let's see. Screen. This might be an inconvenience, but we're just going to have to move on ahead. Thank you for the advice. I'm actually pretty bad with PowerPoint. So yeah, this metaphor of a toolbox, how you have different tools in the Azure ecosystem. And I want you guys to understand what kind of tools DocumentDB and HDInsight are. With a better understanding of what these tools are, you'll be able to better understand when these apply, how these interact with each other, and you can move that forward to build great applications. So here's a quick agenda of what we'll cover. We'll do a short overview of Azure DocumentDB for those who don't know or aren't familiar with DocumentDB. We'll do a short introduction to Azure HDInsight for those not familiar with HDInsight. And then we'll cover using Hadoop and DocumentDB. And then we'll dig a little deeper and go into using Storm and DocumentDB. I think that one's a real cool one, so look forward to that. Next. So introducing DocumentDB. DocumentDB is Azure's NoSQL document database as a service. So the big question is, what is NoSQL? How many people know what NoSQL is? Yes, good, awesome. So NoSQL, it actually stands for not only SQL. SQL is the tabular relationship based data modeling. And NoSQL is everything besides that. So what's included in the family of NoSQL. You have your columns data store. You have your key value. You have your graph. You have your document data store. As you can imagine, DocumentDB is a document data store. It's very clever naming. And it's used for storing semi-structured data. With that, you can use DocumentDB to store JSON data. How does that look like? No, it is not used for storing Word documents. That is one of the biggest confusions, and that is one of the most common questions I always get. Can I store my Word documents in DocumentDB? It is definitely not meant for that. However, if you have metadata and you decide to store that within JSON documents, we'll gladly accept it. If you're planning on just storing your Word docs straight into the document database, then it'll be very difficult, and it probably won't work out well for you. So what do we accept? We accept JSON. We are natively supporting JSON, which means when we're sending data over the wire, it's in JSON. When we store it, it's in JSON, and when we send it back, it's in JSON. Even our indexing is based off of JSON. So you can see a quick JSON document right there. You have the property name, John. You have the property country as Canada, and you have the property age as 43, and you have a property last use as March 4th, 2014. There we go. So how does this actually apply to DocumentDB for those that are curious? As you can see with document 1, this is the same document I showed you before. It has John, Canada, 43, March 4th, 2014. As you can see with document 2, it is slightly different. You don't see the last use property. This is where the schema flexibility of a document store really comes into play. You don't need to actually have the last use property. We accept any type of JSON document, and it could be stored all together in the same place. As you can see with document 3, there's a first use rather than a last use, which differs from all the rest. And then the fourth one is an aggregation document. Within the aggregation document, you have your doc count, which is set to 3. As you can see, 1, 2, 3 are before it. And it has a last, May 1st, 2014. So how does this actually work, right? I'm sure some of you are curious as to, when you query for this information, how does it actually work? So let's say you did a simple query where you wanted to select people.age, right, from this collection. So people.age from people, right? So it will return back 4 documents. However, since the last one doesn't actually have the age property, it'll just return an empty curly brackets thing inside. But you'll actually get 43, 25, and 22 for the other ones in JSON. They will be returned back as JSON. Also I wanted to mention, if any of you guys have questions, feel free to end. If they're short ones, I'll answer them gladly. If they're a bit longer, we can wait until the end, and I'll gladly answer them here, booth, or anytime. If you tweet at us at documentdb.com, we'll come and answer it as well. Yeah, this is pretty casual, so if you guys feel like you have questions, please just raise your hand. Feel free. Yep. So if you have an application, you send queries to DocumentDB. They don't only need to be queries. You can send stored proc executions. You can have triggers that actually run in the background. And if you do send a query, you'll get JSON back. So these are kind of the 4 key capabilities of DocumentDB. These are a real strong point. So this is something I really want to cover for you guys. The first one, flexible schema and queryable. As you guys have seen, flexible schema means your data doesn't need to fit with a rigid schema. Where does this really come into play? Let's say you're a developer starting a new application. Rather than spending weeks, months, a long time thinking about data modeling, thinking about what kind of data model you'll use, you can actually quickly, rapidly develop. And as your data modeling changes, you can push the new schema to DocumentDB, and we'll gladly accept it. We also support rich queryability. Our query syntax is based off of the traditional SQL syntax. Last session, John got asked a question. This is weird, right? This is NoSQL, but you're using SQL syntax. It's bizarre, right? It's like you're saying you're doing one thing and then you're doing the other, which is not actually true, because it's not only SQL in the fact that the data modeling is based off of flexible schemas, and We know that people who are coming to use this are most familiar with SQL. So why teach a new querying language, make it difficult for users to actually use DocumentDB when we can use the traditional SQL syntax? Next, multi-document transactions. We actually support JavaScript multi-document transactions. So if you have a store procedure, and let's say you're updating multiple documents, either they all happen or none of them happens. It'll roll back. So when's the use case? When is a good time to actually use this? Let's say you have customers stored in your document database, and they're transferring money, right? This is the classic example. They have $10. One guy, customer A has $10, and he's transferring $10 to customer B. Where is this an issue? Let's say customer A, gets subtracted $10. Customer B doesn't actually receive the $10 because it fails halfway through. If it doesn't roll back, then $10 is missing, right? This is unacceptable for some modern applications that require transactions. Next, it's tunable and fast. So tunable, there's usually two levels, strong and eventual. How many people know about strong and eventual? Less hands. I feel like people are tiring out. So strong and eventual, which is basically, there are two very separate categories. So we thought we can fit in two extra ones, which are bounded staleness as well as session. Session is more of if a user writes to DocumentDB, they're guaranteed to see their own read. And bounded staleness is just how much seconds or how many operations can I wait before I need to see it. So it's kind of a bound. You're guaranteed to see it after a certain point, but up until that point, there's no guarantee. And then scalable and fully managed. DocumentDB is a full Azure service. And as an Azure service, we are fully managed and we are scalable. We GA'd 4.8, so about a month ago. And these are two key things, right? Because managing clusters is difficult. I'm not sure how many of you have tried to manage clusters, but it's honestly quite a challenge. And having it fully managed means if something goes down, if something goes wrong, we're here to make it right. We're here to fix it. You don't need to wake up in the middle of the night to fix it because we're here and we're going to fix it. Also, you can just head to the portal, go into the DocumentDB Blade, and quickly create a DocumentDB account within 5 to 10 minutes. It's very fast. You can get started very quickly, and this is ideal for new developers who want to start up fast and start developing quickly. So I have a quick demo for you guys. I put in quite a bit of demos in here because I know I like demos. I'm sure you guys like demos. So I have a quick demo for you guys. A customer will interact with my web app. I didn't actually push it onto Azure website, but it is definitely a possibility. And it is actually, if you want to have it around in different Azure data centers, talking to the database, I recommend you push it to Azure websites. And it's built off of Azure DocumentDB. What's the actual data inside? Well, I have user profiles and comments, and I also have Chicago food inspections, which is a little weird, I understand. I actually like food a lot. I was looking for open data that was related to food, and I stumbled upon food inspections, which is definitely not as good as the food data. But I'm sure you guys will find it interesting. I kind of do. And then below is just a short disclaimer about the data. So we'll head into the actual demo. There we go. So this is a short demo that I've made using DocumentDB. This is food in Chicago. A little bit deceptive because this is food inspections in Chicago, but I apologize. It's a simple web application using Azure DocumentDB to store Chicago food inspections, users, and comments. I'll scroll over to the next slide. So this is where it gets interesting. As you can see right there, right below the top nav bar, you can see my picture. It has my first name, last name, my title, as well as the company I work for. This is one document in DocumentDB. Within there, I've also stored favorites. So a list of favorite restaurants I have. I actually haven't been to any of these, but they look really good from their websites. Yeah, so I have a list of the favorite restaurants, just name, right? Not the full documents. And as you can see, this is what populates the top part as well as the leftmost part, the favorites column. You can also see it says Welcome Andy on the top, where it uses my first name, which is pulled from DocumentDB. And you can have history. So you can see the history of food inspections for Miko Sushi. And I could show you just how fast it is to pull the rest. So if I click Baskin-Robbins, which is actually quite large because it's not a single Baskin-Robbins in Chicago. It's every Baskin-Robbins in Chicago. And this is all the food inspection data. So you can see that this is JSON. You can see, past violations they've had. You can see dates. You can see the name they go by, address, pass, failed. This is, a lot of information. I find that Hayward Tavern has been interesting just because this is a new restaurant. As a new restaurant, you go through multiple inspections, right? Right before you go live, you have to make sure everything passes. And you can see that. So they've had, I think, 3 inspections within 3 days. The first one they failed just because, a new restaurant coming out is not ready to go yet. You can see that right over here. I think I'll zoom in because this is pretty hard to see for you guys. There we go. So you can see this. The risk level is high. I'd like to clarify, it doesn't actually mean it's dangerous. It doesn't mean if you go to the restaurant, you'll get sick immediately. It's actually quite the opposite. I found when the risk level is very low, it means that they're using a lot of packaged foods. There are a lot of preservatives, safe foods. So like hot dog stands as well as ice cream stands, they'll have a pretty low risk rating. The higher ones are when they actually get fresh ingredients, they prepare themselves, they prep it themselves, and so they'll have a higher risk. So please don't assume that this is kind of dangerous to go. And so this is one of the actual food inspections, and I'll scroll over. Oops, let me just get out of that. Scroll up, and you can see that they've had one on March 31st. And most recently, let me just refresh that. Sorry about that. Here we go. Zoom in and, oops. Hayward Tavern. And this is their most recent one. And you can see their results are pass. And so the next one is, we'll get into comments. These comments are separate documents. They're only linked to me by user. The user is set to Andy. So if I query for user equals Andy, I'll get a list of all the comments. As you can see some of the comments here, I have, Miko Sushi is amazing, the best sushi I've ever had. These are, better, easier to read than the JSON docs I've showed you before. And that's what I really wanted to show you here. And also, I've added the functionality of being able to edit these. So Baskin-Robbins has 31 flavors to choose from, and they all look really good. And I list some of the flavors, but I say the best will always be blank. What kind of ice cream do you guys like? Chocolate? Very nice. We'll keep it. We need to actually update the document. Anything new? Mocha almond fudge. Sounds very good. Mocha almond fudge. Very good. I push it, and now it's in DocumentDB updated. The consistency level is session, which means if I read it, I'm guaranteed to actually see the updates. So let's go back to the... There we go. OK. So that was a simple web app. A simple web app based off of DocumentDB, just to show some of the schema-free or the schema-flexible nature of DocumentDB. Let's go into Hadoop. Yeah, sure. Oh. This is not shared on GitHub, but I can share it on GitHub later. Yeah, thank you. Okay. Wait, just in first. I'll reach after. Yeah.
You had very good structure in your data in this case.
Mm-hmm.
Why did you use DocumentDB? What's the advantage
So,
against SQL databases?
great question. So he's wondering why I use DocumentDB when I had great structure within this. So the thing was, all of these documents, they have slightly different structure. As you can see, the comments varies from user profile and varies from violations. And if I have many of these documents, I want them in DocumentDB so that I can query, let's say, I want to query for everyone or every user that's Andy, as well as comments that's Andy, and it'll return me the list of documents, and all of them will return, the user profile, as well as all the comments related to me, right? This is one quick query rather than having to join tables, right? There was a question over there, yeah?
Are you able to encrypt the documents?
Am I able to iterate?
Encrypt.
Encrypt the documents. We don't actually support data encryption as of today, but we are looking into it. Yeah. Another question?
You mentioned multi-document transactions.
Mm-hmm.
Does it include documents from multiple collections as well?
So transactions are based within a collection. Actually, I should repeat that question for everyone else. Is multi-document transactions across multiple collections? It's only based within a single collection because it is a partition. So imagine it to be almost like a single machine. And within there, we provide ACID transactions. So we'll start with Hadoop. As I've asked before, I kind of asked for people who know Hadoop, and it was a solid amount of people, so we'll just do a brief overview of it. It is Apache's open source project. Hadoop is based on top of the Hadoop distributed file system, which is basically putting data in multiple different systems so that you can do parallel processing. The distributing processing on data nodes is what makes it very unique as well as very fast. So what is it actually based on top of? It's based off of commodity hardware. Because as your data grows, you can scale by putting more commodity machines onto it. So data volumes. Incoming data, or data that people want to run batch jobs on, batch Hadoop jobs on, are getting larger and larger every year. And so there's been this need to do distributed processing in order to get useful aggregations as well as useful analytics from this. Data variety. The data incoming into or being stored within the cloud, they're coming from many different applications now. As you know, phones, they have mobile applications out there, websites. They can all send data to the cloud, but how do you actually put it all together? How do you make something useful out of it? How do you understand the data coming in? How do you make aggregations on it that will give you some insightful knowledge? And data velocity. So this is actually a two-part thing. Data velocity is incoming data. It's coming faster and faster. The amount of data that's being sent over from major companies are gigabytes, terabytes a day. Also, people now want aggregations and also insights instantly. They want it in real time. This is becoming a need where people want to understand their data as soon as it comes in. So let me give you an introduction to HDInsight. HDInsight is scalable and fully managed, as you guys know. It means that you can deploy a Hadoop cluster in about 15 to 20 minutes. Very quick. You can deploy a 200-node cluster in 15 to 20 minutes. I'm not sure how many people try to do a Hadoop cluster setup, but it's very difficult. They've extracted that out, and they basically provide it as a service. It's flexible, so Hadoop can ingest structured, semi-structured, and unstructured data. As you guys can see, DocumentDB is part of the semi-structured, and it's customizable. A couple of months ago, they've released script action, where you get to put in PowerShell scripts to customize your HDInsight clusters, your Hadoop clusters, so that you can use some of the latest and greatest open source projects, part of the Hadoop ecosystem. This includes Solar, Giraffe, and also our Hadoop connector, DocumentDB's Hadoop connector. Okay. Introducing HDInsight. So HDInsight is Microsoft's cloud Hadoop offering. It's 100% open source Apache Hadoop. This doesn't mean that Microsoft, is just taking what's out there open source and putting it on. We actually contribute back to the original source, the open source trunk, I would say, of where Apache Hadoop is stored. It's built on the latest releases, so you'll expect to find the latest releases on the HDInsight clusters. You're up and running in a minute. So in 15 to 20 minutes, you have a 200-node Hadoop cluster, which is amazing, phenomenal. You can harness existing .NET and Java skills to write MapReduce jobs. The HDInsight team understands that .NET is one of those things where if you're part of Microsoft, many of the users will know .NET. And so they've decided to put a lot of energy into making tools so that people can use .NET to write MapReduce jobs. And you can use familiar BI tools for analysis, including Microsoft Excel. You can use Power Query to pump data from Hadoop into Microsoft Excel. Data visualization, you get great graphs, charts. Yeah. So now we get into the meat of the talk. DocumentDB plus HDInsight. This is what everybody here has come for. So DocumentDB has a Hadoop connector for HDInsight where if you use script actions, you can actually deploy it, and then you can talk with DocumentDB. We released this mid-February, close to Strata time, so it's been a couple of months. One of the big customers that are using us today is Azure. I'm not sure how many people are familiar with Azure. They're based in Nashville, Tennessee. They're basically ensuring that hundreds of millions of devices and appliances stay online. That's kind of what they do. And they're using DocumentDB, HDInsight, and their Hadoop connector to talk between these two services. So what's their use case? How does this apply to you? How do you get value of what they're doing? Their use cases, they do batch processing of data across multiple DocumentDB collections. So this is the scope. So DocumentDB collections is a scope. I've told you before, consider it to be kind of like machines, right? You can use HDInsight to pump in terabytes of data, or the Hadoop connector to pump in terabytes of data into HDInsight, and you can run complex aggregations on them to extract the useful information, to extract useful things. What's their second use case? They use it for storing the Hadoop job results in DocumentDB. This is actually, I think, one of the best parts of it. They understand that DocumentDB is easy to work with. Making web applications with DocumentDB on the back end is easy. So storing their Hadoop jobs in DocumentDB means you have it indexed, you have it easily available, and you can quickly make applications on top of it. One of the other things they've covered is DocumentDB supports 5 SDKs: .NET, Java, Node.js, JavaScript, and Python. With their 5 SDKs, we appeal to a number of developers. No matter what language you learn, right? As long as it's covered there, you can use DocumentDB. So DocumentDB's Hadoop connector is open sourced on GitHub. You can find it on the link below, github.com/azure/azure-documentdb.hadoop. It supports Hive, Pig, and MapReduce. How many people are familiar with Hive, Pig, and MapReduce? Okay, not as much. Or people are tiring out. So Hive, Pig, and MapReduce are the different ways you can interact with the Hadoop clusters. You can submit Hive jobs, you can submit Pig jobs, you can submit MapReduce jobs. And then there's easy deployment through script action. I've talked about this before. You can use the PowerShell script that we actually provide to easily deploy this onto the HDInsight clusters. And I'll show you that right now. So we'll go back to my computer. There we go. Okay. So I'll head over to the Azure Management Portal. Azure Management Portal. I'll log into my personal account. As this is loading up, I want to mention that HDInsight clusters use blob storage as their Hadoop distributed file system. So you need a blob storage account in order to deploy a cluster. As you can see here, I have one. This is titled Ignite Demo 2. Somebody took Ignite Demo 1, also without the number. And so I'll go to HDInsight, create an HDInsight cluster. This is all logged on our documentation. So if you can't remember it here, you guys can just head over there. And then I'll name it Ignite Demo 2. Next. Data nodes, I'll keep it to 4. So this is important. I need to choose the region that my storage account is located in order to actually deploy the HDInsight cluster. This is because if it's not located in the same region, the biggest hit you'll take is latency. Transferring data over the wire, that's where most of the time wasted will be. And so they force you to use the same region as your storage account. I think I use West US. I configure a username and password. Oops. I use an existing storage account. Right now it's trying to figure out what kind of default container I should use. It's running a little slow. Could be the internet access here. Let me try that again quickly. It seems to have stuck. So HDInsight isn't actually on the new portal yet, but they are migrating soon. Yep.
Is this currently offered on the government portal?
I'm not actually too sure, but I can double check for you. It's not. I think somebody said it's not. There we go. So it's actually, and I'll create a default container. And this is where the magic happens. This is where you use script action to install DocumentDB Hadoop connector onto the HDInsight cluster. I'll just quickly get the link from here. This is our service page. Go to documentation. And there's actually an article that says analyze. This is run a Hadoop job. We're using DocumentDB and HDInsight. I'll just get the PowerShell script and I'll add it in. Ignite testing or Ignite demo. And there we go. So this is creating my HDInsight cluster. So last step was script action. I added the custom PowerShell script. There's a link on the actual tutorial we have on our documentation page. So what it does is it downloads the PowerShell script from wherever we host it. We host it on blob storage. It downloads it, and it runs it on the HDInsight clusters. You can choose either the head nodes or worker nodes, but I chose all nodes. So every node will use the PowerShell script to install the other packages, which is our Hadoop connector. Exactly. And so let's switch back. So DocumentDB to HDInsight. What are the benefits? What are the benefits of actually using DocumentDB and HDInsight together? I gave a quick overview of each service separately, and now let's cover what kind of synergy do you get when you use both of these services. First of all, Hadoop is open source, widely used. We thought with DocumentDB connecting to Hadoop, there are so many new opportunities, right? You can build great applications using the Hadoop ecosystem as well as DocumentDB. So one of the benefits DocumentDB gives to Hadoop jobs, you can actually push queries to DocumentDB so that you filter the data before actually sending it into the HDInsight clusters. But what does that mean, right? What does it actually mean? It means, let's say I have product documents within DocumentDB, millions of them. I just need to find out which one is the latest. Latest, 100. That's it. I don't actually need to send the entire document over. I just need to send over the timestamp that says the date at which it was last modified. Why send the entire document over when I just need that? And that reduces the amount of work that Hadoop actually needs to do to process the data. So I push a query in to DocumentDB saying, hey, just give me the ID as well as the timestamp of last modified. I send that to HDInsight, much less data to actually process. What benefits does DocumentDB get from using HDInsight? I think, as we mentioned before, collections are partitions. So running aggregations across multiple collections, across databases, this is very difficult to do, right? So you can actually pump the data to HDInsight, and you can run these aggregations through the Hadoop clusters. You also get to combine your DocumentDB data with other sources. This is a big benefit. Hadoop can already pull data from SQL, can already pull data from blob storage. Now it could pull data from DocumentDB. So what kind of scenarios unlocks here? You have this kind of, you can build an IoT scenario. Imagine you have event logs. You store the metadata within DocumentDB. So let's say product profiles. I have, let's just choose something random. Let's imagine I have cars. And I just want to know, I store all the event logs in storage because there'll be massive amounts of raw data pumping into it. I have the metadata in DocumentDB. And let's say in the event log, something has gone wrong. Something has gone terribly wrong. How do I merge this data together? How can I actually combine my DocumentDB data, which is actually used for quick querying, and my blob storage data so that I can figure out what's going wrong? So I combine it together in HDInsight, and I can run aggregations on it to figure out, match the data together. I have another demo for you guys where I pump the Chicago food data into HDInsight, and I run Hive queries on them. How many people are familiar with Hive? It's getting less and less. People are forgetting knowledge as we go on. So Hive is based off of SQL. So if you're familiar with SQL, you'll have an easy time using Hive. And I can show you that right now. This is the Hive editor. HDInsight actually provides this. You can run Hive jobs from here. I have a Hive job ready. And this is all distinct facilities. So what am I doing here? What's actually the logic behind this? Zoom in. So this is making a table using DocumentDB, and then it is selecting distinct name and streets from all Chicago facilities. Why did I include street? Because as I mentioned before, Dunkin' Donuts has tons of facilities. I can't group them all together because they're all different, right? And then I sort by name. So I can submit this. I actually have the results already done over here, which we can check out. So this is what you get. You have your job query on the top. The more interesting thing is over here, the output. So this is the list of output of all the facilities that came out of our Hive job. There we go. See over here. It's quite long list. And then we can run in a new Hive job while the previous is running. Here. This one's a little more interesting. Rather than just getting a list of all facilities, this one gets average risk, average associated risk. So how does this work? It takes in data from DocumentDB, pushes a query in for inspection year of 2015 and 14. We don't want outdated data. We're just getting the 14 and 15 data. So I'm not sure if you guys can see, so I'll zoom in. And then we get rid of things where people didn't actually complete the inspection, which is risk level 1, 2, 3. That's how they labeled it. And then at the very end, we get places that don't have longitude and latitudes. We filter that out as well. And then what do we do with it? So we format it. So we round it off to 2 points, 2 decimal points for latitude and longitude. And then we find the average risk for that longitude, latitude, that point. We count the risk, the number of times it appears. And then we pump that back, or we get the output, and then I pump that back into DocumentDB. There is a way to pump it back. And we'll run this. So let's name this, have to submit this. And this one is this Hive job. Over here. It's just a list of longitude and latitudes with the average risk involved. 2.0, 1.5. Remember, risk isn't too bad. It means if you're preparing your own food, getting raw food, you could have a higher risk. Food stands tend to have lower risk. And so I'll pop back out, head back to, okay. Yep, question?
The demo you showed, was that running against DocumentDB?
Yes. So what happens is, so he was asking if it was running against DocumentDB or Hadoop. So the DocumentDB Hadoop connector actually pushes data from DocumentDB into the HDInsight clusters or into Hadoop. So the actual MapReduce job isn't actually running on DocumentDB. It's running on HDInsight. The nice thing about it, though, is since DocumentDB and HDInsight are on the same cluster, you're using Azure's internal network to transfer data. This is very fast. They've optimized for it, right? Okay. So HDInsight to Hadoop. This is one of the use cases I would really like to highlight. This is beneficial. This is kind of one of the things that Azure has talked about, how they're pumping data into DocumentDB so that it's easy to use. So what are the benefits that you get? You get to automatically index your analytic results, right? DocumentDB automatically indexes the documents that are coming in. I'm not sure how many people are familiar with HBase, but managing indexes is hard. Everybody has come together and said managing indexes are hard. So DocumentDB automatically does that for you. You have flexible schemas. Your analytic results will vary depending on what type of job you run on it. The information it carries will differ. You can put that all in DocumentDB, one place, and it'll easily accept it. You get to query against resulting analytics in real time. This is a benefit, right? Hadoop is batch processing, which means you submit a Hadoop job, you wait 30 minutes, maybe an hour, 2 hours. You get the results, and then you can look at it, right? But how do you repeatedly access it? You can store it either in HBase, you can store it in blob storage, or you can store it in DocumentDB. Storing it in DocumentDB means you have these already indexed, already available. You can easily make applications to use them. Right? And that comes to the third point. You get to leverage multiple SDKs. Right? I've talked about how we have 5 SDKs, .NET, Java, Python, Node.js, and JavaScript. With these 5 SDKs, you have options to make different types of applications, especially for rapid development, especially if you need something to get going very fast, very quickly. Got another demo. So we kind of done pieces of this, right? As you can see, we have a customer. He's interacting with the website. The website is backed on DocumentDB. You have your food inspections, user profiles, and comments, something we've covered. Something new has been added, right? We've pumped the data into HDInsight. We ran the jobs. We had results. Now we pump back to DocumentDB. So how do you actually link this all together? How do you make an application that uses all of this together, a full-blown application, right? So I have a demo for you guys where we kind of link it together and we kind of show you some of the potential. Okay. So back to this classic website where we last left off. We submitted an edit to the comment. Scroll over to the next panel. So what did we get with the first Hive job? We got a list of all unique facilities, right? We used the address as well as their name because we didn't want repeats of Dunkin' Donuts, right? Or other type of chain restaurants. With this massive list, we have now a kind of explorer where we can see, different types of data very easily. Let me zoom in a little bit. As you can see, this is data pulled straight from the Chicago data set. And then we can explore further. We can go in and see the results. So I can go in and see the history. Comes back very quickly. It's hitting DocumentDB in West US. You have their history, something we've seen before, right? But now we have the additional option of, let's go to a different letter. We have another list. This is the results we got from Hive. We can list it all out. And once again, we can click on them to dig deeper. And we can see their food inspection history. Some of them are unique. Some of them are fun. I'm not here to bash restaurants or other places, so we'll move on. So what was the next query we ran? We ran a query that got the average risk for longitude and latitude. A bit more interesting data, right? Rather than getting a distinct list of facilities. Very simple query. So now we have average risk for longitude and latitude. It'd be cool to see a heat map, right? Just to see a heat map of longitude and latitudes. Green is for low risk. Red is for high risk. So I've added that into the site. It's a little bit, I think the resolution is changing with the website. But yeah. So this would actually be flushed out to the right. But the resolution of this monitor is actually changing things. But yeah, it would be flushed out to the right. The red, there's a lot of red there, so don't be too scared. It doesn't actually mean that the next restaurant you go, you'll probably get food poisoning. I'm not here to actually spread fear to everyone. It actually just means your ingredients are fresh, right? Maybe these restaurants are actually getting them fresh, preparing it themselves. If anything, the green is probably something you want to avoid because that's probably more of the prepackaged food. You'll probably see a lot of ice cream stands. Low danger, low risk, but what's life without a little bit of risk, right? Good food comes with high risk. Okay, so we'll head back to the presentation. So this is something cool. This is something very recent. Apache Storm. How many people are familiar with Apache Storm again? 3 people now. Nice. So Apache Storm is Apache's open source project. It's distributed, fault-tolerant processing, real-time processing of data nodes. So this varies from what I've shown you before because the last one was batch processing, right? It takes 30 minutes, hour, 2 hours, 3 hours. This is stream. This is real time. So you'll get aggregations coming in as you're running your application. So how does this connect with DocumentDB? This isn't the same slide as before. This is different. It's similar mentality, though, right? It's the fact that as you're pushing, the Storm output into DocumentDB, Storm can't actually store the data. You can store it on DocumentDB, though. You store it on DocumentDB. You can have it automatically indexed. You can actually access it very quickly. You can build applications with it. You can query against these analytics in real time. I'll show you that later. This is important, right? So let's say if you're getting Twitter trends coming in real time, you want to actually see them. You want to see that coming in real time. If DocumentDB can't give you that data in real time, then what's the point, right? What's the point of having real-time analytics if you can't access it in real time? And the last point is something that's been said multiple times, and I can't emphasize this enough. It's the simplicity of DocumentDB. It's the fact that we have documentation out there. It's the fact that we have all of these SDKs out there. I don't know how many Hadoop users there are out there, but Hadoop changes very quickly, very quickly. It's open source, which means people make contributions. I know if I don't keep up with news, the Hadoop news, I'm lost after a week or 2 weeks. It moves very fast. It's very rapid. DocumentDB is a full Azure service, so we make sure that if there are changes, you're notified. We make sure that you know what's changing. We make sure that it won't impact your application. So this is the last demo, the final demo, the one that I'm sure many of you guys came here to see. This is the last piece that came in. So we have the customer. He interacts with the website. The website can be stored in Azure website. You can publish it there. That talks to DocumentDB. DocumentDB stores Chicago food inspections, user profiles, comments, data analytics, and this also includes the data that's incoming from HDInsight's Storm. And then it also talks on the other end to HDInsight Hadoop for the great heat map as well as the data explorer we saw before. So let's go into this demo. Oh, question? Yep. Mm-hmm. No. It's pumping data to DocumentDB. Yep. Storm to DocumentDB. Yeah. So I want to clarify. Actually, I can clarify with this. Storm is part of the Hadoop ecosystem, right? But the reason why I say it's different is just for the fact that if I go here, and if I go create a new one, they give you options of Hadoop as well as a Storm cluster, right? And so when I say it's not pumping into Hadoop, it actually is going through Hadoop in the sense that it covers Storm, but within HDInsight, it's the actual Storm clusters it's going through, not the Hadoop ones. Yeah, just for clarification. To 2 different places. So yeah, from DocumentDB, it goes to the Hadoop for batch processing, right? And for the real-time analytics, it comes in from Storm. Yeah, did that answer your question? Okay. So where were we? So I made this really quickly. This was kind of, I wanted to make the idea of connecting to Storm something demoable, right? If it's not demoable, it's still not an idea. It's not something that you can apply. I want to show you that I actually applied this knowledge, right? So rather than spinning up a new one and waiting for the Storm cluster, I can run this locally, the topology locally. It won't stream the data as fast, but it'll still stream the data into DocumentDB. It's running. Yep. And then we'll start this. This will backfill some of the data. This collection had some data already inside, so it'll backfill that. And then as the Storm data is coming in, it'll start showing that as well. So this is a trending, Microsoft Twitter trending small app within a bigger app. So what is this actually doing? This is taking data from Storm, filtering on some keywords. The keywords are kind of arbitrary Microsoft words. I use Microsoft, Ignite, Xbox, Windows, some of the big terms so that the tweets would still keep coming in. And it's filling into DocumentDB. And then the actual application is just reading. It's just saying, hey, the newest documents, give that to me, in batches of 10. If there's not 10, then just give me whatever you have available, and then we'll pump it through. I stopped it there. If you guys are curious, I can restart that, though. OK. Let's switch back.
So once it catches up,
It'll slow down.
it'll slow down, and then you'll only see it every so often, updating with whatever.
As fast as Storm is pushing it in, right? Yeah. If I actually posted this in HDInsight, and I had hundreds of nodes or such, it would be much more data flowing in, right? And if I use more key terms, right? Maybe I use keywords that are almost everything, or all the restaurants in Chicago. I could have done that. Obviously, the keywords would have to be exact matching, right? Because people who put hashtags, they can capitalize certain things. They can misspell things. It won't actually catch that. So additional resources. I just want to do a quick overview on what we've covered, as well as if you guys have questions, this is a good time to ask them, right? Because we're going to slow down. Oh, we have a couple questions there. Blue? Yeah, sure.
You were running the Hive queries through Azure, and then the web app was running those very same Hive queries?
No. I've actually ran it, pumped it into DocumentDB so the data persists in there, and then I access it. Running the Hive queries would mean that it would be a batch job, which means it's not real time. You won't be able to access this in real time. So it's best to do it in a batch job, save it, access it, and you can run these jobs every once in a while, maybe every 4 hours, every day, and then the data would constantly update. Yeah, question behind it? So if you pair HDInsight with SQL Server, bottlenecks. So what do you mean by bottlenecks? Is this strictly just HDInsight and where is it SQL? I haven't actually connected it with just SQL and HDInsight, so I'm not really sure about that. But I can't imagine there would be any bottlenecks. You can use Scoop to just get the data out, I think. It should be fairly easy. Yeah. There was another question over there. I see. So Stream Analytics is separate. However, we are working on building connectivity with them as well. Stream Analytics is C#-based, right? .NET. And it fits in well because it's the same premise as Storm, except it's geared towards the people who are familiar with something different, right? And we are actually in the works of building that as well. So yeah, you'll see that in some time, yeah, on the roadmap. So any more questions?
You're running almost the same query, Hadoop and Storm, right?
No, different queries. So yes, different languages. So the actual query for Hadoop, HiveQL, it's Hive's SQL-like language. That's what I use to actually run that. And for the query for Storm, Storm actually uses its own type of unique syntax. So that's something different. You can use our Java SDK to actually integrate with them. Very easy. I found Storm to be very easy to work with. But yeah, two different types of ways of doing it. I found Storm is similar to MapReduce, where you actually write it in Java. Yes. There's another question over there.
The operational insights where now OMS service is leveraging DocumentDB or HDInsight on the back end?
Not that I'm aware of. No. There's another one.
Yeah, I was wondering, you've got a really low-factored relational database SQL Server. Is there any kind of tool to kind of jumpstart working with DocumentDB to just analyze the database? If somebody's not doing anything fancy, just load them up on a
So jump-started as in run Hadoop jobs on it and then into DocumentDB, or bring it over to DocumentDB and then run? We have this import tool, which can actually take data from SQL and then it could put into DocumentDB. John actually covered that in his talk, and I can actually, if you come afterwards, I can give you the link and stuff, yeah, to get you started. Yeah, awesome. Yeah, I can actually share that now. I think we still have some time. So we had a blog post come out about importing it from SQL Server. If you follow this, you can easily import data into DocumentDB. Yeah. This link is over here. I can zoom into it to make it easier for you guys. There we go. Yeah. Another question? Huh? Oh, yeah. I think I can edit it, and then I can add this in for everyone who's curious. Yeah, go ahead.
So does the DocumentDB pipeline the data into Azure and then process it?
Yep.
Does that transaction, does the data have to stay there? Can you have persistent data in the Hadoop cluster?
Yes, you can. So if you persist data in the Hadoop cluster, you can save it in blob storage. The problem with blob storage is it doesn't really manage indexes. So you'll have a hard time getting the actual subsets of data within it. That's why if you need the data and you need to index into it, we recommend using DocumentDB. If you just need to save the data, right, the cheaper option would be to use blob storage, which is actually built into or is the HDFS of the Hadoop clusters. Yeah, great question.
So DocumentDB, you're saying automatically indexes?
Yes, DocumentDB automatically indexes your JSON docs. You can also sending an index policy. So I'll go into this a little bit. So we have automatic indexing. So if you just send in a document, we can automatically index it. We also allow you to set your own indexing policy so that you can, let's say you only access certain properties. You know for a fact you only access certain properties. You can set those properties in the indexing policy so that the time it takes to actually index your newly written document is shorter. So you get performance boosts.
So comparing HDFS, is DocumentDB's data stored in a blob storage as well?
DocumentDB's data is stored separately. It's not stored in blob storage. It's stored in our own system, our own clusters.
And you have clusters of those, or just one?
One cluster or multiple clusters? We have multiple clusters. Wait, what's the question? Like, as in replicas?
You have a cluster so you can leverage parallel.
Oh, we have multiple.
You have the same thing.
We have multiple, and they're separated by collections. This is the idea of collections, partitions. Exactly, sharding. Yep, great question. Okay, so let's quickly go over this because we're running out of time. Additional resources. So these are some of the additional resources if you want to get started with DocumentDB and HDInsight. The first one is your simple Hive, Pig, or MapReduce job, whichever you're most comfortable with. The second one is we have a sample project out there, DocumentDB plus Storm. This is a good way of getting started, getting familiar with DocumentDB and how it interacts with Storm. Next, if you're unfamiliar with DocumentDB, you can hit our Getting Started page. And if you're unfamiliar with HDInsight, you can go to our Getting Started with HDInsight. Yeah. And I think there's a couple of slides that were added in that I should cover. So I'm not actually sure what this is because this has been added in. I think this is for rating your speaker. But yeah, next slide would be, there's an Ignite Azure Challenge Sweepstakes. You can use the session code, and you can enter online. There's some great prizes out there. I think Xbox One, Fitbands, and Surfaces. So make sure you take a picture of that. Okay. And then last one is just evaluate the session. So I guess I'm not sure what the first one was. Yeah, that's just been added in. They threw me a curveball. Evaluate the session. You can use the QR code. And thank you. Thank you for your time. If you have additional questions, feel free to ask them. I'm sure you guys are hungry. It's time for lunch. Yeah, back. Oh, this? Yeah.